Hi friends, welcome to the NPTEL course Strategy and Technology, a practical primer. We are in week 9 with the theme of technology as strategic driver. In this lecture, which is the 45th in the series, we discuss the topic of technology and change. We have considered in our earlier discussions that product design continuously evolves over time. It brings new features and functionalities to the users or the customers. And this evolution typically occurs in phases of time or over several generations of products. The theory of competitive strategy emphasizes the critical role of competition, but more competition does not necessarily mean that there will be better customer service, because there are several industry level factors that are involved in it. We thought about and talked about fragmentation, for example, declining industry. All of these are characterized by excessive competition, but they don't provide higher level of customer satisfaction. Technological stagnation can hide within technological modernization unless strategy goes beyond economics or diseconomics of change. So change and the direction of change is an extremely important aspect of technology strategy and the consequent business strategy. The interface between a firm and its customers must be seen as a collaborative socio-economic interaction rather than as a transactional competitive play. Regulation by governments oftentimes reassets consumer interests. It is for the benefit of consumers. Technology guides regulation and also enables firms address regulation in a positive manner. This lecture focuses on how technology in its various shades can provide competitive edge to the companies. Ignoring the importance of technology would lead to negative consequences. Let's see design evolution in terms of product design. Product design continuously evolves over time. It brings new features and functionalities, all right. But how does it generate itself in terms of the evolution? There are four aspects. One, user unfriendly. That is, the original product design appears to be heavily outdated and user unfriendly. Therefore, the new technology comes in and this makes it even more unfriendly. So the user unfriendliness of the existing technology, existing product, is one of the ways in which the new design evolution is seen positively. But that is a negative way of going into the positive. The other one is design optimization. That is, there is a design which is good enough or which we think meets the current requirements, but it is not good in certain aspects. It could be form factor as an example, or the hardware could be updated, the software could be updated or better integrated. All of these can be re-optimized to provide a better user experience. So instead of looking at the previous paradigm, which is making an unfriendly product friendly product, we can look at a reasonable product to be further optimized. The third approach is design upgrade. It also is supported by process optimization so that the redesigned product has all the right build characteristics such as fits and tolerances, elegance, durability, reliability and maintainability. That is the third aspect of design evolution. And the fourth aspect is design opportunism. That is, when some product attributes are tweaked up a bit so that others stay as they are. So it is a kind of opportunistic design upgrade which gives a feeling of a new product but actually is not a new product. So when the externals of an automobile are changed but the internals remain the same, then it is design opportunism. It is not really a design upgrade. These are the four ways in which design evolution could take place in the normal circumstances. But some of these have design incongruity built into it. They don't fulfill the customer expectations in totality. Looking at a negative product and comparing it with a positive product is not really helpful. Optimization of design doesn't take the product into a new trajectory. Design upgrade also doesn't take the product to a new trajectory. Design opportunism is worse because it tries to confuse the customer in terms of certain spikes in the design which are assumed to be representing a brand new design, whereas it is actually not so. So we need to have a better paradigm of design evolution. But before that, because the customer is incapable of asking for a total demand upgrade, which requires totally new products, And because he settles for short-term improvements in the product, we may say that tweaked products rule the roost generally in the normal industrial situation. The customer has only a fleeting contact with the product or service. That is, let's say you are using a mic and you don't use the mic all through the 24 hours. You use it only in a fleeting manner when the requirement is there, in which case you will not be able to measure its strength, is utility. It is not same as, let's say, using earbuds continuously, where you need real design upgrade, a noise cancelling system and a low loss system. Therefore, the time of contact which the customer has with the product is a big determinant of design opportunism that could play a role. The product or service has several performance attributes, of which only one is a dominant one, in which case also the integrated nature of product upgradation is not appreciated by the customer. The customer is not well-to-do and is not discerning at all, in which case industries can walk away with giving less than desirable products. The suppliers themselves are monopolistic and unwilling to update their own products or services, that means sellers' markets. The buyers have no choice. The industry itself exists in a monopoly state, and the firm has certain attributes even within a competent industry, and therefore the company has a dominant status and a preferred firm status. In terms of Porter's 5-strategy theory, the situation which I have described is one where the bargaining power of customers is weak and the bargaining power of suppliers is strong. However, the three other competitive forces can vary in their occurrence. There could be a presence or lack of substitute products. There could be higher or lower level of rivalry in the industry, and there may or may not be high barriers to entry. This incongruity could be sharper when the product and business competition increases, but without corresponding improvements in all facets of customer service. 100% desirable design evolution should not be opportunistic. It should be holistic, wholesome, and should include product as well as the process. It should include the style as well as the substance. There are peaks and valleys how technological evolution takes place. There are certain striking examples of stagnation hiding within technological modernization, even in industry settings of intense competition and liberal customer spend. There also exist examples of total upgradation. Let us take air travel. Billions of dollars are spent on buying aircraft by the airline companies, and the technology involved is the most modern, most contemporary and futuristic. Yet, the comfort level that is offered in air travel within an aircraft is one of high congestion and in some cases of poor hygiene as well. And when you look at the other mobility solution on ground, that is automobile, the drives still have clutches, particularly in the commercial vehicle sector. When you look at retailing and warehousing, you will find that huge amounts of stocking space is wasted. So a lot of technological modernization is happening in terms of the aircraft, in terms of the automobiles, in terms of the malls and the warehouses, but the inner core somehow seems to suffer. Why is it happening? Because there is an intense focus on revenue, how to maximize seating capacity. There is intense focus on cost, how to drive down the cost. And there is an intense movement towards safety. Why not have a buffer so that we never run out of stock? Instead of trying to plan just in time, people would like to have as much as possible in stock. The above three examples and the key issues briefly mentioned above are discussed in the upcoming slides. Let's talk about the air travel. It is a congested comfort, to say the least. The large commercial aircraft makers, though just two, that is Airbus and Boeing, are engaged in an unending search for technological superiority, while the airlines themselves compete rather fiercely and the customers theoretically have several choices. Over the years, there has been a quantum jump in the technology of aircraft design and air travel in terms of the larger aircraft size, the greater seating capacity, higher automation in piloting, flatbed seating technologies, audiovisual entertainment, automated baggage transportation, and so on. Yet there are two areas which just stagnated in customer service through all these decades of aircraft and air travel modernization. One, the toilets remain congested and pitifully inadequate in terms of size, service options, and hygiene levels. The food galleys and the food carriage hardware remain conventional, unhygienic, and unfriendly. None of these has influenced either the aircraft makers or the airline companies to offer flexible and more hygienic food choices, more spacious toilets and restrooms, preferably separated for men and women, and improved legroom dispensation to the travelers. It hasn't happened. Why? Because revenue maximization has been the theme. The customer power, despite there being millions of air travelers, all of them educated and well positioned, willing to spend millions of dollars collectively, remains woefully weak. This is a case where the market situation and industry situation cries for upgradation and has all the features of upgradation. Yet what happens in these two areas is woefully inadequate and it is obsolete by decades. Let's look at automobile mobility. The automobile has been a marvel of modern and continually improving technology. From horsepower to fuel economy, as well as from cruise control to passenger safety, hardware and software are continuously updated to provide improved road commuting experience. Hybrid cars and electric cars are leading a new era in automobile design and performance with low consumption and clean emissions. However, the automobile manufacturers, especially in the emerging markets, are not able to completely do away with clutches and manual gear shifts, and this would rank as one of the shortfalls of design management. Nowhere else it is evident more than in the Indian truck and bus designs, which still employ very hard clutches and inefficient gear change levers. Constant mesh gearboxes still exist in the on-road designs. Despite the intense competition, automotive makers and customers see an automatic transmission as a premium luxury offering with higher price realization than as a minimum requirement for driving comfort, on par with seat backs for driver and passenger safety. The market hasn't evolved to accept factory-built air-conditioned cabs or low-floor buses which are designed with monocoque construction and which only big companies can undertake. The customers thus seem to be disinterested or unable to engineer a total shift towards driving comfort and efficiency. This is the second example. When you look at retail and stores, whether it is a bookstore, a grocery store, or an electronics store, and whether it is in a developed country or a developing country, the stocking and display methods are somewhat similar, that is, subpar. Shelf space in physical retail is important. With the spiraling real estate costs, most retailers tend to use vertical racks from ground to, say, a 6-foot level to pack their wares. Most consumers do not look at the products placed below the waist level or those stocked behind their other products. And they also don't look at products which are above the eye level. This not only reduces the sales potential but also leads to non-moving and expired products. Despite the severe competition in retail space, and the millions of dollars spent on malls, display formats, promotion, and advertising, few retailers have innovated to ensure complete and comfortable visibility and accessibility to all their merchandise. Ergonomics, that is so much a part of industrial design, seems to be rather ignored in the retail and stocking space. Customers also, unfortunately, do not seem to be eager on having a complete product scrutiny before making their purchasing decisions. This has resulted in wasteful or injudicious use of storage and circulation spaces. We have thus seen three examples of technology being available specifically in products, yet some pockets of product performance being way behind what they should be. The examples explained in the previous slides from three different industry sectors, all characterized by intense competition, great customer dependence, and continuous product or service evolution, illustrate that even as technological development reaches its peaks, it hides the valleys of technological obsolescence. So there are some hypotheses which are not probably fully true. In fact, they are not true. One hypothesis: intense competition leads to better customer choice. Not necessarily true. Example, airline seats. Pitch is so narrow, so small that you are even likely to get DVT as a disease if you stay for more than 8 hours in the same position. or for some old people, even 3 hours in that position could be fatal. Product variety means better choice for consumers. Not necessarily true. We have commodity products which offer huge product variety, but do they mean better specifications, better features? No. Great customer dependence great dependence on customers means better innovation in firms. Not necessarily true again. Public transport systems. Public transport systems require huge number of people to transport and be viable. But are they offering better public transport systems, better passenger comfort? No. Innovation is a permanent culture. Not necessarily true. There are so many innovators who have failed that this hypothesis is also not true, and we have seen examples in the previous lectures of failed innovations and failed businesses. Whether it is Palm, PDA or Pebble, there have been failures. Regulation by public policy is counterproductive. Not necessarily true. Banking, finance and telecom have benefited from certain level of regulation. Although over-regulation can kill a sector, as demonstrated by telecom in India. Technology strategy does not lead to easy hypothesis. That is the summary of this. The way technology is deployed must be specific to the markets and products while maintaining the secular uptrend of development. We have to constantly evaluate the economics of change versus the economics or diseconomics of no change. The decisions to continue to embed or cover up outdated technologies and practices in modern developments as discussed above, or keep renewing only the internals while retaining the outdated exteriors as in the case of some desktop computers, are often dictated by the firm level economics of change versus no change. All airlines seem to observe a unified approach in not competing for customers' switch with breakthrough comforts. The economics of air travel are dictated by available aircraft space for seating and minimum possible seat pitch and width on one hand. High fuel and maintenance costs, ground costs and wage bills and taxes on the other hand. The incentive or compulsion for providing comfort, hygiene and service must come therefore from strident customer demands for comfort as much as from quantum leaps in technological efficiency of aircraft design and operation. Both have to occur. Technology must take forward aircraft design, seat design, toilet design, food galley design far in advance of the current requirements. Similarly, there must be technological efficiency for enhancing the fuel economy, lowering the maintenance and making switches at the ground very fast. There must be twin incentive mechanisms operating that way. The situation in respect of automobiles could be different because of the more realizable on-ground product design nature. The updates to engines, gearboxes, body exteriors or internal trims in an automobile may come with increased competition and with a bid to switch customer loyalties. This would be more true of personal transportation rather than of public or cargo transportation. A transportation service that is based on trucks and buses may prefer to consider only incremental changes. The design efficiency of a transportation equipment, be it an aircraft or an automobile, need not necessarily translate itself into improved delivery of customer service that is based on such equipment. If the service providers do not face compulsions or have incentives to provide better and safer delivery with more advanced designs, the design efficiency will not be completely seen through the customer value chain. So there must be some pressure from the customer side as well as a pressure from the manufacturer side to elevate the nature of the transportation service. It is a simultaneous push and simultaneous pull system that must operate. When you want to change versus do not change, there are companies that are wholly dedicated to retail, which must be focusing entirely on stocking efficiency, but they do not seem to care. There are several stuck in the middle apparatus or devices such as storage racks, where minor innovations can provide major improvements in quality of work or business, but they are ignored. The reasons relate to the insensitivity of the managements to missed sales opportunities and the impatience of the customers to look for a total choice. There is a case in design thinking of people buying based on hand baggage carts, and someone noticed that that was limiting the amount of products that can be bought in a stores and also the weight that can be carried. So the brilliant idea having the trolley baggage carts came in, which was extremely comfortable for the buyers to take products and put it into the shopping cart and also move around freely. That was a great innovation, but it is in terms of the pickup. But what about the storage racks themselves? Are they having similar kinds of upgrades? Similar improvements in processes can improve productivity of social interactions, quality of life, both in and through various governmental and non-governmental structures, which are not thought about or insisted upon. There could be several ways by which the service providers can trade with their users the benefits of eliminating periodic transaction efforts, say monthly, for the costs of one-time payments, say annually. What we do in terms of annual purchases of certain digital subscriptions can well be introduced in several retailing experiences as well. A durable and assured service quality would help the users to collaboratively work with service providers to minimize transaction efforts and costs. So how do we reassert these forces? The theory of competitive forces does not always work either to the advantage of the firm or to the advantage of the customer. On the other hand, the behaviors of the firm and the customers are likely to be inconsistent when viewed from a pure competitive framework. Competition is not just automatically generating better customer service, better product evolution. We need to work consciously towards that. Where customer loyalty and firm offerings are driven by certain dominant commercial dimensions, actually, Porter's theory of competition leads to incongruous results simply because generic industry factors do not apply to specific customer needs. A few examples. Despite the presence of many airliners to choose from, the air traveler simply and typically chooses only one airline of his choice or her choice because of loyalty mileage points. In respect of automobiles, ease and access of service is a tipping point. Despite the presence of multiple smart devices, the IT security policy of a firm could limit the choice to just one vendor for smart devices. So, availability of competition may be thwarted, may be circumvented, or may be ignored because of customers and administrators' linkage with just one factor. The various competitive forces mentioned, such as industry rivalry, cease to be of importance in such instances. Monopoly firm conditions prevail, with customers choosing by themselves to weaken their bargaining power over the use of a product or service. This is a self-inflicted negativism on the customer psyche that we cannot and need not apply the pressure which we could put in terms of our heightened expectations. Instead, they agree to whatever is offered. It would be in the fitness of things for the firms to collaboratively work with the users to optimize the interplay of competitive and collaborative forces, a topic which I have dealt with at significant length in the previous lectures. Firms have industry associations for participation and constructive development of norms and standards to channel competitive forces on collaborative lines. We should have universal unified standards for bus designs, low-floor buses, for example. We should have standards for electric vehicles so that there are no unseemly fires plaguing the customer psychology. It is important that these associations and channels are passively utilized to bring about the required improvements, without economics being the sole arbiter of corporate strategy or consumer preferences. Similarly, citizen groups and neighborhood communities can collaborate on the best ways to optimize social interactions through the good offices of governmental and non-governmental agencies. The air transportation market has, for example, the Air Travelers Associations. These should serve to enhance the bargaining power of the customers, that is, the air travelers. The crux of the matter is that not all aspects of a firm customer interface can be viewed or managed through the framework of competitive strategy. It requires additional apparatus to make the power or the expectations of the consumers felt on the industry. Similarly, the industry is motivated to learn from the silent feedback of the customer group and modify its products and services. So we have to reassert the forces of competition. And there is a huge role for regulation. Interestingly, regulation by the government acts as a stabilizing force when competitive or collaborative forces go astray. In India, each of the cellular service providers had significant bargaining power over the cellular telephone users until the Government of India introduced number portability. Despite the existence of several alternative service providers, the mobile telephone users in India had little choice, as the need to switch numbers along with service provider forced the users to stay with the originally chosen telecom service operator. A more genuine choice came about when the number portability got introduced. The hand of regulators in optimizing industry-society interactions has been seen in the developed world too. There were intransigent cases of design improvements which were not leading to delivery improvements. There were delivery shortfalls actually, and it required governmental interventions to stabilize the firm user interaction. The EPA fuel economy norms that were introduced in the USA in the 1970s, particularly from the West Coast, the state of California, or the institution of safety standards in respect of several products by several governments across the globe fall into that category, where the government stepped in to enhance the safety standards or performance standards and made the industry raise the expectations for itself and for the customers. Similarly, the stipulation of Basel norms for prudential bank management reflect the stabilizing nature of regulation. The climate standards that are being done and worked out at governmental level are putting a lot of pressure on industries to get into a net zero situation sooner than later. Should regulation be a force that restores the competitive forces in a skewed industry or market situation? There is a question. Governments can provide to the consumers what years of apparently intense competition could fail to achieve. Governments have the ability to provide in one stroke a quantum jump in customer service. For example, they can simply say aircraft should have a higher seat pitch to avoid blood circulation problems to air travelers in the economy class. Just one prescription. What could not be achieved over decades of airliner competition could happen through that. Similarly, we can resort to sin tax to curb potentially harmful excesses of sugar, hyper-processed foods, tobacco and alcohol. To date, the Indian government has been using its regulatory powers with a stated social purpose. For example, banks should have certain number or proportion of rural branches, or their lending to private sector should conform to certain norms. As the economy develops, but as inequities also continue vis-a-vis the super rich class, the government may have to step into more areas to stimulate the impact of competitive forces for greater equity. Corporate hospitals, for example, may be required to reserve certain free beds for indigent population. Governments had to intervene to moderate the cost of RT-PCR testing for COVID passengers in airports as well as for COVID patients in the broader society. Hospital bed costs had to be regulated. Vaccine are being provided free so that the entire nation would not see that as an obstacle, but instead would go motivated to get vaccinated. So there are certain national objectives which the governments follow and which will be very helpful for industry to change itself and the market to change itself. Portability of insurance and investment schemes without exit loads may also be prescribed. Mutual fund industry has undergone significant change in terms of proper definition of what each fund would like to do, what each scheme would need to do. That is a consumer awareness move. Firms and industries as well as strategy makers need to look beyond competitive strategy to optimize technological development for holistic benefit to the society. I would take an example of shipping industry. This is not an industry which we commonly discuss in terms of progress because shipping is considered an established old-fashioned industry. But lots of things are happening in the shipping industry. We should recognize that what is not seen by us when the ships sail into the blue ocean are things where there is no technology. We can't assume like that. In fact, technology is driving many developments in the shipping industry. Fundamentally, there is a collaborative innovation within the maritime sector. To ensure future competitiveness of the maritime industry in post-pandemic times, we need an efficient, predictable, sustainable and resilient shipping industry. After the semiconductor price increases, after the steel and other metal price increases, The supply chain costs have been one of the greatest triggers for input cost increases, and that has happened because of the pressures on the shipping systems and on the maritime sector. We need a change in recipe for capital creation of involved actors, a change in mindset to overcome industry with existing legacy systems and silo thinking. So, maritime sector qualified as one of the sectors where not much attention has been paid for technological modernization, and thankfully it is seeing such a change. We have 4,900 ports across the world, but they are not using even for basic process digital technologies. 80% of the ports still continue to rely on manual legacy solutions such as whiteboards or spreadsheets to manage critical marine services such as towage, pilotage, and berthing. Collaboration between traditional industry leaders and startups therefore must rise, and maritime testbeds and accelerators that are emerging must be happening with greater intensity. In August 2019, Immersat, Cargotec, Shell, HHLEA, and Wärtsilä launched the second cycle of Trade and Transport Impact Program in search for 10 mature startups. Singapore's largest shipping company, Eastern Pacific Shipping, teamed up with investor and accelerator Techstars to create a space where innovation is accelerated. Innovation efforts are also enabling simultaneously reducing costs and reducing the impact of ports and shipping sector on the environment. A case of joint venture between Hamburger Hafen and Hyperloop TT, a crowd-powered company and innovator by design, is an example. This collaborative innovation intends to move containers at the speed of sound through a vacuum tube, an enclosed, highly reliable system connecting ports with their hinterland in a new way, reducing time and carbon emissions. And Hyperloop has been one of the most out-of-the-box suggestions that was getting pursued by Elon Musk of Tesla. We also had the Morocco Smart Port Challenge in 2020, which looked at managing high volume flows of trucks in peak times leading to congestion, delays and increased carbon emissions, and having a virtual line app to control that. The problem of fighting climate change that requires carbon neutral energy production was also attacked through this hackathon. The transition to electronic payments instead of physical payments such as check and cash by increased transparency, cutting through red tape and reduced fees. A port tech payment team has proposed a solution for this. So maritime industry is seeing whiffs of change in several areas, direct and indirect. There are 5 technological revolutions that are sweeping in this shipping industry now. Blockchain technology. The shipping system based on blockchain technology will make it easy to transfer data and track cargo in real time till it reaches the destination. The second, which I referred to briefly, the Hyperloop transport system, an idea conceptualized by Elon Musk. This is a transport system that will carry people or cargo from one destination to another via a tube at a speed of more than 700 mph, and several underwater transportation movements can take place with this, and probably billions of dollars of operational cost would be saved each year. Robotics, research institutes and companies in the automobile, transport, tech sector can collaborate to build robots that can aid in ship management, safety, servicing and inspection. Saphir is one example, shipboard autonomous firefighting robot being developed by the US Navy Research Lab in collaboration with Virginia Tech. Who knows, Boston Dynamics, which we discussed earlier, could also come up with its own robotics to help the shipping industry. Augmented reality in shipping can optimize cargo planning, aid maintenance and inspection, navigation, and connect global teams. Port 360 is a virtual tour of the Port of Rotterdam, and this is an example of technology being used for connecting with businesses. Smart ships. Just as we are talking about smart automobiles, connected automobiles, autonomous automobiles, we need to consider automated ships also. These will add a technological edge to the shipping industry. World's first zero-emission container vessel, Yara Birkeland, was launched to sea on a day in February 2020. There are transformation technologies that are occurring in the shipping industry, not known to many. Autonomous vessels, employing Internet of Things, artificial intelligence, neural networks, advanced navigation, and 5G. Commercial shipping and management operations, again applying IoT and also fleet management systems. Internet of vessels and digital platforms, applying AI, weather data and shipbuilding technologies. Trade, finance and logistics, applying IoT and blockchain. Digital technologies and solutions for shipping are intertwined with related technologies and supply chain solutions. Robotics is changing the maritime industry. Robots are now used for many purposes in the maritime industry, from cleaning and maintenance to fully autonomous vessels with no pilot, no captain and no crew on board. SeaKit's Max Limer is a great example of a fully robotic ship. It can travel autonomously, accompanied by several small drone boats and submarines, which it can send to carry out various tasks. SeaKit has been partnered by the US administration to build robotic vessels for oil refining, the work which is incredibly dangerous for workers who are regularly exposed to chemicals and toxic fumes. Huge ships such as Panamax are difficult to test due to the surface area of the ship, materials and paint used. A team of students from ETH Zurich and ZHDK teamed up with Alstom Inspection Robotics to create a lightweight and versatile ship inspection robot. I talked about already Sapphire Firefighter robot, which can look at as an autonomous humanoid robot, fires detection, extinguishing aboard a ship and working side by side with human firefighters using advanced technology. So huge strides are getting taken. Artificial intelligence itself will be one prime area of development. More and more forward-thinking shipping organizations see AI and machine learning as keys to achieving a competitive advantage. AI-based predictive positioning systems will enable shipmasters and bridge teams to monitor and predict future positions, movements and maneuvers of their vessels hours in advance, improving situational awareness, decision making and ultimately safety. ML/AI technologies are currently able to give an economic effect from the use, optimize and increase the efficiency of a shipping company. Fuel optimization system and others are prime examples. Digital ship twins are possible. Autonomous ships are possible. There are innovative companies disrupting the shipping industry, therefore. I have given some example. Freightos for more digital freight forwarding. Flexport for digitalized shipping on a web-based platform. Marine Traffic, a community-based project for real-time shipping movement information. Holland Container Innovations, that comes for a foldable freight container. Octopi, a web-based TOS which drastically improves productivity in terminal ports. These are all the examples of innovation occurring in the startup space of the shipping industry. Nautics Technologies makes shipping industry safer and more efficient. IO Currents, it is a Seattle-based company increasing uptime and efficiency through predictive edge analytics platform. KNL Networks simplified the digitalization of vessels by providing an end-to-end digital solution. FuelSave tries to combine own innovations with market-leading suppliers and components to provide solutions for combustion efficiency enhancement, energy storage, energy recuperation, and waste heat recovery. C-Log provides a blockchain-enabled platform for secured identification. Cross-industry data collaboration, linking stakeholders from the entire maritime value chain in a trust system, is made feasible by this startup. We know that the global maritime industry is one of the most important aspects of globalization. Not everything can be carried by air cargo. Shipping has been the key driver for globalization for several centuries, and even in the modern century, shipping will continue to be a very important link, a very important connectivity between various nations. It will be an important driver of global trade and globalization. The international maritime trade has been going up consistently, and it has the potential to even go up higher. We need newer technological solutions, which again prompt newer business strategies by shipping companies to be able to make the due contribution to the ocean mobility, cross-border mobility, cross-continental mobility through maritime trade. We can look at not only these kinds of developments, but also individual enhancements. We can reduce the reduction of negative effects of underwater radiated noise, which is an extremely important thing to protect ocean ecology, we can have propeller designs which are changing towards making quieter ships. We have a revolutionary new technology capable of substantially reducing the underwater radiated noise that is generated by ships' propeller cavitation. It is a UK-based innovation. Maersk, the Danish shipping company, spent more than $100 million in 2017 to save fuel by retrofitting vessels' hulls and installing more efficient propellers on 11 of its container craft. Total, a French energy company, designed, built and tested a marine version of Hyperloop, a quieter proven seismic surveying technology already used on land. It doesn't generate more harmful frequencies produced by traditional surveying. Therefore, it reduces the survey time and also protects the marine life. So these are the kinds of individual technological developments that are happening in subsegments of the maritime value chain. And there is a fuel that could be transforming shipping. Today, the shipping industry currently emits 3% of all greenhouse gases. To keep temperatures within safe limits, we will have to decarbonize in the shipping industry as well. A small ferry is running on a fuel that many hope could hold the key to decarbonizing ships everywhere. The fuel being tested is on Hydroville, a 16-passenger shuttle moving between Quebec and Antwerp, and hydrogen fuel, which we will discuss at a point later in our discussions, is the one which is transforming the shipping in that region. CMB is already building several other hydrogen-powered boats, including a larger 80% ferry in Japan, set for launch in early 2021. It takes a lot of energy to haul a ship through the water, and there are an increasing number of ships to haul as world trade grows. To cut emissions, some of the energy could be reduced through ships that use more efficient designs, as we have seen earlier, by installing technologies to harness wind, going a bit slower to conserve fuel, and finally changing the fuel itself to hydrogen. There is also going to be another important development, which is the autonomous ships. Autonomous ships will transform the industry, and the current regulations are being reassessed to determine the best way to include this futuristic way of shipping. 4 degrees of autonomy. Automobiles have 6 levels of autonomy. Shipping will have 4 degrees of autonomy. The lowest degree of autonomy involves automated process that can control the ship at times. Seafarers will remain in charge of operating and controlling the ship when the automated system is not activated. The second degree is a remotely controlled ship with seafarers still on board. The ship will be controlled from another location, but the seafarers on board will be able to take control if necessary. The third degree is a remotely controlled ship without any seafarers on board. And lastly, the highest degree of autonomy is a fully autonomous unmanned ship that is equipped with the ability to make decisions and take action by itself. Several companies have begun already implementing autonomous capabilities into their ships, and the technology is rapidly developing. And electric ships, just as we are thinking of electric automobiles, electric ships are going to come in. Market researchers have calculated that one single large ship emits as much CO2 as 70,000 cars, as much nitrogen oxide as 2 million cars, and as much fine dust and carcinogenic particles as 2.5 million cars. Out of the total global air emissions, shipping accounts for 18 to 30% of the nitrogen oxide. Because of this, ships are amongst the most serious sources of pollution in seaports. So, electrification of ships is an important strategic direction that the shipping industry must take. So, a fully electric ferry has been sailing on the river Mosel in Germany since spring 2018, and that has been successful. And 6.5 hours is the journey time. China has the first fully electric container ship, initially as a trial on Pearl River in southern China. It is planned only for use on internal waterways, as the ship can travel just 80 kilometers. The 1,000 lithium-ion batteries on board weigh 26 tons and achieve 2,400 kilowatt-hour of energy. India's largest shipyard, Cochin Shipyard, has now commissioned Siemens Energy to supply the drive and battery components for the first 23 of a total of 78 planned electric ferries. The electric ferries are to be used in the mass transport system of the coastal metropolis of Kochi in the southwest India. Their task will be to connect the city and its 10 islands via 38 different terminals. India, therefore, is also taking great strides in the field of electric ships. We are also likely to get the world's first artificial intelligence ship sooner or later. A team of researchers from the Marine Research Organization, Propeller, in collaboration with IBM, built the world's first AI ship, the Mayflower 400. It is an unmanned 15-meter long trimaran that weighs 9 tons and it is completely autonomous. It is packed with technologies such as LiDAR and radars that are used in autonomous cars. And this will help in detecting multiple hazards in the path from miles ahead. It will also come with onboard cars for better sailing, automatic identification system to keep a tab on weight, speed, etc., and global positioning system for specifying location, speed, and course. Already, the model has been trained on 1 million of nautical images collected from cameras and open source databases. And IBM powerful computers are being used to run this computer and to test this computer. Along with this, IBM also used its computer vision technology to enable the ship to detect and classify objects, avoiding crashes. The ship has been equipped with a smart captain and artificial intelligence technology. The ship also has 6 high-tech cameras and radars to help the ship learn during its course. This is artificial intelligence coupled with machine learning. These are the keynotes on the maritime industry and its technological developments. So the business strategy in maritime industry is going to be dependent on the kind of technological upgradation that would take place, finally driving down the supply chain costs and reducing the impact on the environment, making the ocean life safer, well protected. Thank you for your attention. We'll meet next week.